Good morning, everyone. This lesson is about Venn diagrams, and I'm going to use this in order for us to understand better some of the terms and principles about sets. All right, so diagrams make mathematics easier because they help us to see the whole situation at a glance. Now, there's an English mathematician, John Venn, used diagrams to represent sets. And now that diagram is called the Venn diagram. So to give you an illustration of that, we have this example. So this larger set is called the universal set. So you see that E there, and inside that letter E, there's a rectangle because we normally use a large rectangle for a universal set. Now, all those letters, obviously, I believe you know that those are the letters in the English alphabet. And you see that's an A, E, IOU, they are inside a small circle. So that's called a subset of the universal set. So you see that letter V there, obviously those are vowels. So more on subset. So we represent subset in a Venn diagram. So when we know that S is subset of T, we place the circle representing S inside a circle representing T. For example, so there is a subset of S, all right, and that's 0, 1, and 2. And then there's the universal set T. It is composed of 0, 1, 2, 3, and 4. So as you can see here, we encircled 1, 0, and 2. That's set S, which is a subset of the original. So then set S is a subset of T, as illustrated in the Venn diagram below. So another concept that we need to understand is how are we going to represent intersection in terms of Venn diagram. So in this example, we have two different sets, M and N. So for letter M, as you can see, there's 1, 2, 3, 4, and 5. These are the numbers. And then for N, we have 4, 5, 6, and 7. Now there are two common elements among the two sets, and that's 4 and 5. So how are we going to represent that as a Venn diagram? As you can see here, we have the two circles, M and N, and then there's an intersection between those two. All right, that's 4 and 5. As you can see, if we only consider, let's say, set M, there you go. 4 and 5 is still included to that set. Now, if we only consider set N, again, still 4 and 5 is part of that set. All right, so you have this intersection 4 and 5 for the two sets. So that's how we illustrate or represent intersection using Venn diagram. Now, the union of two sets is a set containing all elements that are both in A and B. Okay, this is written as A union B. Now, here in this situation, we don't have any intersection whatsoever. So for set A, we have 1, 3, 5, 7, and 9. Those are odd numbers. And then for set B, we have these even numbers 0, 2, 4, 6, and 8. Okay? So the intersection of the two is a null set. There's no intersection. But if we combine the two, that's the union, which is equivalent to the universal set. Okay? So this in the previous example, we call that disjoint set. So two sets are called disjoint if they have no elements in common, just like the previous example. So here we have two sets, x and y. For set x, we have 1, 4, 7, and 9. And for y, we have 2, 3, 6, and 8. There's no common element among the two sets. We call the sets disjoint. All right, and I think that's it for today. And just take note of the things that we had today because we will be using the concept of sets and Venn diagram to solve problems. And we will do that. We will be doing that in the next video. Thank you for watching. Have a nice day. Bye.